Okay, so hello everyone. Thank you so much for participating in this event. Today we are very delighted to be hosting Dr. Hugo Tranin um, from ICCUB, University of Barcelona. And so a little bit of brief introduction. He obtained his PhD from IRAP in Toulouse, France in 2022. And the focus of this PhD was on X-ray astrophysics, especially on ultraluminous X-ray sources. And he was basically searching for the intermediate mass black holes using XMM Newton data. And he's also part of the Black Gem collaboration, which is a telescope of arrays in La Silla and mainly focused on discoveries around the electromagnetic counterparts of gravitational waves. At the moment, he's a postdoctoral researcher at the Institute of Cosmos Sciences of the University of Barcelona. And he's again working on the luminous red nova. And today he's going to talk about relegate, which is a French word originally, apparently, and it's got a very unique tradition around it. So I highly recommend you to check it out. So, Hugo, the floor is yours. Please take it away. And thank you so much for accepting our invitation.
Thank you so much for the introduction, and thank you all for being here. So yeah, thank you for. So today I will present REGALADE, which is a new all-sky galaxy catalog, which is now in press for astronomy and astrophysics, and you can check the article at this archive ID that I put everywhere in the slides as well. So yeah, it's a galaxy catalog optimized for transient science. Um, So yeah, well, why do you need a galaxy catalog first? So one reason is that since 2017, we know that gravitational wave events can have electromagnetic counterparts, but the error region of gravitational wave event is huge, several square degrees. So there are thousands of galaxies in there, and yeah, it's a very large field to target. So we can narrow down the search around the most likely hosts by using a galaxy catalog. The most widely used galaxy compilation so far is GLADE Plus. So it's a compilation of 23 million galaxies. And another reason why you want a complete galaxy catalog is the large volume of transient science. So ZTF already discovered thousands of supernovae each year, and LSST will soon deliver millions of alerts each night. So if you have a galaxy catalog that allows you to distinguish between galactic and extragalactic targets easily, and also to, if you have the distance, to compute the absolute magnitude, which is very helpful to have a clue of the nature of the transient. But well, to get this host transient association, you need the size for the galaxy. Yeah, and reliable galaxy catalogs are reliable galaxy distances, sorry, and associations are surprisingly hard to get beyond 100 megaparsec or so because of the galaxy catalog incompleteness or lack of data. Yeah, so here's the problem. You have recent deep surveys, legacy survey to name, but a few. I'm illustrating here the legacy survey DR10, and but these deep survey are not integrated yet in galaxy catalogs, in galaxy compilation covering the whole sky. So of course you have some galaxy catalogs using just these parts, but you don't cover the whole sky then. And yeah, you can use a compilation, for example, GLADE Plus, which compiles 6 catalogs prior to 2016. So it starts to get old. Oops. Yeah. Also, yeah, so GLADE Plus and some other galaxy catalogs may contain some contamination, for example, stars or artifacts that are mistaken with galaxies. And when you have an all-sky galaxy catalog, more often than not, you don't have the extent, the ellipse, so you cannot tell if the transient is hosted by this galaxy or not easily as well. So how do you fill this gap and build a better galaxy compilation? So we started by combining catalogs one by one, paying attention to what each one brings to the table. So first step is the Siena Galaxy Atlas. Based on the legacy surveys, it gives us good galaxy shapes and also photometry, but it's not all sky, and it lacks distances. And yeah, it's only a subset of the largest galaxies. Then we added the target selection of the DESI Peculiar Velocity Survey. So it's a catalog of 4 million galaxies, which really boosts the number of galaxies in the nearby universe up to 700 megaparsec. But yeah, and it adds photometric redshift as well. So to get even more coverage, you can use DELV, for example, which adds a lot of galaxies in the south with decent size and photometry, but many of them don't have a photometric redshift because they require to have proper magnitude in the 4 bands to compute the photometric redshift. So again, you get more galaxies, but without a distance, you cannot use them for transient science, basically. Here is another galaxy catalog from the legacy surveys. So it's got better completeness and more distances, but has missing large galaxies, like the one on the right, and some contamination as well. Yeah, Glade Plus is also included. So it's one of the best known compilations as I have introduced, and it covers the whole sky, which is great. And it includes both photometric and spectroscopic redshifts, which is super useful, but it doesn't have the extent of the galaxy, and also lacks some photometric data. So at the end of the day, we obtain REGALADE, which is an all-sky compilation, including nearly 80 million galaxies. So it compiles all these 16 catalogs, 14. I divided NED into 3 subsets. And we have ellipses and distances for the 80 million galaxies. I also mentioned here that it's more pure more pure and complete than previous compilations. So I will show you how. Yeah, and this is the distribution of the final catalog. So yeah, as you can see, it's all sky with better depth in the region where you have the legacy survey footprint. So yeah, to produce the compilation, we match galaxies, the galaxy catalog by sky position and size, using a custom matching radius, custom matching rule illustrated here. So we flagged and rejected objects appearing in just one catalog and within the because some of the objects here are just H2 regions of these large galaxies. So in that case, they were excluded, and also we excluded stars. You can see the illustration here that from several complementary galaxy catalogs you obtain a better compilation. So I mentioned that we removed the stars. So this is using Gaia. So we cross-match all objects to Gaia, and when you have a counterpart within 5 arcseconds, so you can use the Gaia color and the separation to separate stars and galaxies, and you can do the same with a morphological criterion. So objects that are too compact to be a galaxy can be considered as stars. Yeah, if they are not, yeah, well, I, you might think that this excludes quasars, but it's not excluding quasars. Yeah, it's explained in the paper. I can elaborate later if you want. So we combine photometric redshifts, and we have some catalogs providing redshift independent and spectroscopic redshifts distances. So yeah, but so I'm showing here for galaxies having a spectroscopic redshift, the photometric redshift that we have from another catalog. And so this is when you have just one photometric redshift from another catalog. And you can see that the distribution is not quite great. You have a lot of scattered. The photometric redshift is not sufficient to have a proper distance estimate. But when you combine different photometric estimates, you can actually reduce largely the scatter of the distribution. So this is using three photometric redshifts. So by using a lot of different catalogs, we are able to combine photometric redshifts into a quite reliable distance indicator. So yeah, at very low redshifts, you still have some contamination, unfortunately. So we needed visual inspection there. So actually, yeah, you see here 4 examples of galaxy candidates at distance lower than 100 megaparsecs. So yeah, this is a bogus. This is a nearby galaxy. This is a distant galaxy, and these are 2 stars. So we use the galaxy classification platform, and we gathered the votes from 21 experts. So 27,000 classification from 21 experts for a sample of a bit more than 4,000 galaxy candidates in this distance range. So this was this allows us to clean out the contaminants in this range. Yeah, so in terms of completeness, REGALADE significantly outperforms previous catalog, but you might think, how do I get the completeness value? So this is using the Schechter function. You see here, yeah, the luminosity function of galaxies, and so the theoretical one and the observed one in colors in different distance ranges. So basically, by taking the ratio between the two curves, you can compute a completeness value. And this is the result. So completeness is a function of luminosity distance. And yeah, so for luminous galaxies brighter than the Milky Way in order of magnitude, we are complete up to 360 megaparsecs. So except in a very small part of the sky, which corresponds to the galactic plane, where you cannot be complete. We are quite complete compared to previous compilations. So yeah, you see here the distance distribution of REGALADE and some of its components. So the contamination rate is shown here before cleaning as a function of distance. And yeah, you can see that the contamination rate is huge at low distances, and we were able to clean out these contaminants and obtain, yeah, a negligible level of contamination. So yeah, next one is stellar masses and photometry. So we gathered the photometry from pan-stars, from the legacy surveys, and from WISE, so optical and infrared. And this allows us to compute very reliable stellar masses using scaling relations and reference stellar masses from this article. So yeah, I can elaborate later if you want. And yeah, so the final catalog covers the whole sky with great depth, and this includes crowded regions, low galactic latitude zones, and the full southern hemisphere. So you can see the distribution of galaxies at distance lower than 100 megaparsec, and also the full distribution that I showed earlier. So here's a final quick look at how REGALADE compares with previous catalogs. So on the left you have the distance distribution, on the right you have galactic latitude, and the bottom line is that you have a better coverage in the three-dimensional space. So now it's time for science. We tested REGALADE on past detected gravitational wave events. Well, two of them. So the famous GW 170817. So we by combining the location of the galaxy and the distance, we can isolate a sample of targets to follow up. You can do this with GLADE and with REGALADE, and you see here the comparison. So yeah, for the most nearby event, you have a little difference, and for this one, which is an event at 300 megaparsec, you have a lot more galaxies in REGALADE. Yeah, and this is mostly due to the addition of dwarf galaxies. We also tested the catalog to select ultraluminous and hyperluminous sources, X-ray sources. So in short, we are talking about X-ray sources, extragalactic X-ray sources detected by XMM Newton in the outskirts of nearby galaxies, and with a luminosity above the one of a stellar mass black hole, 10 to the 39 Earth per second. So they are very interesting to study. I don't have time to elaborate on that, but yeah, REGALADE recovers more hosts for both ULX and HLX, which are even more extreme objects, hyperluminous X-ray sources, candidate for intermediate mass black holes. And we doubled the number of hosts for HLX. So we also tested, of course, the catalog for transient science using two different magnitude ranges. So, and for both of them, we used the transient name server. So first sample is black gem reported objects. So black gem is an array of telescope in Chile, which can detect transients down up to 21, 22 magnitude. And the median the median of the magnitude it's between 19 and 20, so it's quite faint compared to the next sample, and you can see that for this low luminosity transient we can recover double hosts compared to GLADE. And so the other sample is the sample of supernovae. So because they are classified objects, they are brighter. Because otherwise they could not be classified. So we have 16,700 transients. That's until August 2025 on TNS, and 15,000 of them have a host in REGALADE. So that's a host for 90% of the transients. And also inspecting the missing fraction, you can realize that they often correspond to seemingly hostless supernovae. So yeah, the host is simply not in the catalog because it's not present in the optical image. Yeah, so this is the application we use on the daily basis. So our team is interested in luminous red novae, which are intermediate luminosity optical transients manifesting stellar mergers. So only few examples are known in the Milky Way and a little bit more in nearby galaxies. So you can see here a sample of these transients, of intermediate luminosity optical transients that can be of different types. So yeah, perhaps the most striking feature is that their peak luminosity is between -6 and -16, which is the luminosity gap between cataclysmic variables and supernovae. So we are using REGALADE as the way to analyze new transients every day coming from TNS. So every day you use the catalog of TNS daily updates and cross-match it to the catalog at distance lower than 100 megaparsec. And we can recover we can recover transients in the luminosity gap and decide if we want to follow the MWAP or not. So this is to schedule spectroscopic classification for these interesting transients. So I couldn't resist also to showing nice pictures from Rubin and Euclid. So you see here the Virgo cluster observed by Rubin, and with regulated detection on the right. So all luminous galaxies are well represented. And here is the Perseus cluster, for which we have a shallower coverage because it's at quite low galactic latitude. You don't have legacy survey, but we can still, we can still recover most of these galaxies. So the last slide is about how to access the data. So we have different ways. So maybe first is the Vizier. So the catalog will be available at the CDS on Vizier once the article will be published in the next few days. And if you are already interested in the meantime, you can check this web page, which allows you to query coordinates and have a visualization of galaxies in the field, and also some information on the nearest neighbor, on the closest match. So the coordinates, distance, size, and the catalog it originates from. So and you can also download subsets of the catalog in different right ascension ranges. I should mention as well that you can query any input catalogs here. So you can use this tool if you don't want to use REGALADE but you want to use Glade. I'm fine with that, and you can just type Glade here. So the catalog is this is the complete description of the catalog columns, to show it briefly. It contains magnitude, distance indicators, the error on distance, the standard deviation between distance estimates, the stellar mass. That's it basically. So of course, feel free to contact me if you have any request for the catalog. And so to summarize, REGALADE is a unified catalog with 79 million galaxies within 2000 megaparsec. So it's more complete than any previous compilation, any old sky catalog, because it compiles them. And it combines deep surveys as well and multiple redshifts into reliable distances and stellar masses. And testing on different science cases, it showed improved performance compared to its predecessors. And yeah, it will be made public very soon on this year. Yeah, and in astronomy and astrophysics. So yeah, thank you so much for your attention, and I'm happy to take questions.
Thank you so much. This was a great talk. We stop recording at this point before we're taking the questions.